Hello, everyone, and welcome to our webinar, Beyond the Numbers, Infusing Creativity in Math and Science. My name is Jamie, and I'm excited to be here with you today. I especially appreciate it on a week like this. I know most of us are wrapping up and getting ready for our holiday break, so your time is even more important than ever. So thank you for joining in. We are going to be going through lots of fun ideas today, and so you'll hear some resources from me. You will also have a hyperdoc that has each of those kind of supplements to those ideas within it. So Robin, in a moment, will put that in the chat box. But before I do that, just I wanted to let you know that this webinar is also recorded. So if you want to watch it later or revisit an idea, it will be made available for you. And then, as I mentioned, Robin is joining in with us today as well. Robin, do you want to say hi?
Hi, everybody. Thanks for being here today.
So Robin is here to help with some tech issues if they happen to come up, but also to help us with our polls that we'll be taking today, and also to kind of monitor that chat box. So thank you again. I'm so glad you are here with us. So I want to talk first about our sponsor, Blue Apple. Blue Apple projects are PBL units for teachers who want to stand out and essentially make a difference. These projects engage students, they teach the content you need to teach, and ultimately make the world a little bit of a better place. So if you have any interest in those, we have a really great offer going on right now. You could save 50% right now with the code HOLIDAY2021. So if you have any spark of interest in trying out PBL, now is the time to jump in and try those out. So blueappleteacher.org is where you could go to learn more, or feel free just to email me. I could help answer any questions you have as well. So I would like to do a quick check-in as we get started, just checking in to see who is here today. So if you could just quickly answer this poll, what grade of students do you teach? And Robin's going to launch that for us.
Yep, they're coming in.
All right, and feel
Give
free.
it a couple more seconds.
Perfect.
All right, looks like they are in.
Awesome.
All right, so Jamie, we are at 50% elementary, 33% middle school, 8% high school, and 8% admin other.
Awesome. Okay. Well, we have stuff for everyone that is here today, so that's exciting. So with that, we'll kind of talk about our creative road ahead. So we're going to talk why, what, and how. And we're going to start that conversation with the why. So why is creativity important when we're talking about math and science? I love this quote by Albert Einstein. Creativity is intelligence having fun. And, you know, really we can't have creativity without intelligence. We can't have intelligence without creativity. And they work in unison. So I think it's important to think about that anytime we're teaching those subjects where we may not immediately think to add creativity within them or include it in some way. So another important reason is that attitude towards the subjects that we're teaching really does matter. And when we talk specifically to say math, a recent Stanford study found that, you know, if you have, or if our students have a strong interest and feel like they're actually good at math, the results show that they actually do better. And so, so again, it kind of talks to that idea that, you know, the way our kids feel about the subjects we're teaching really does play into how well they actually learn it. So a good study there, and that link is within that hyperdoc, I believe, as well too. But I want to imagine this a second. So imagine if we taught art the same way that we teach math. So you give your students a color by number, and you tell them the colors that they have to use and where exactly they have to place those colors, and essentially telling them how to do it, right? And so, you know, they turn one in and you give them another, and they turn another one in, you give them another. And then sometimes, like this is shown in this picture here with the dog, we take away some of the lines, but ultimately we're still kind of guiding them and telling them exactly what we want them to do. Well, thank goodness we don't teach art that way, right? So, but essentially, when we teach math, and we can think about this with a lot of the sciences too, this is what we're doing. And so, you know, the numbers and the symbols change, but it's still that same kind of color by number idea, just over and over again, right? So they do a worksheet, they turn it in, they do a worksheet, and they turn it in. And we know that worksheets, the idea that practice and that that kind of rote learning is important because they do need to know this stuff. They do need to practice it. But one thing I want you to think about today is what's a way that we can think about between the worksheets? How can we really build in activities that really do accentuate and bring out the creativity within math and science? So one thing we know about creativity is that it motivates students to learn. It promotes higher order cognitive skills. It also can engage our hard to reach students. So the students who might not take tests well. What's another way that we can reach them? Well, through creative practices is a great example. We could use different creative ways to do that. It also spurs emotional development. So, and I think almost maybe the most important thing on here is that it's an essential job skill in today's ever-changing world. And what we have to teach our kids to prepare for today looks very different than it did even 10 years ago, and very different than it did 20 years ago. And so when we look at these top 10 skills of 2025 that came out through the World Economic Forum, I went through and circled all of the skills that I thought kind of related to creativity, and we could probably make an argument for every single one of them here, but these ones come out kind of a little you kind of hold that weight a little heavier. So analytical thinking and innovation, complex problem solving, creativity, it says it right there, originality and initiative, also technology, design and programming, and then reasoning, problem solving, and ideation. All of those things, very directly relate back to that idea of creativity. So, so it really is essential that we are building in opportunities for our students to learn in this way. And these three students you see here we want to say they're exceptions, right? These are kind of creative geniuses, and I'll tell you a bit about them in a moment. But the reason I bring this up is because I want to point out that these students are sitting in our classrooms each and every day. So Amber Yang is an 18-year-old who came up with an artificial neural network to kind of identify where space trash lives. NASA adopted it, and that's the program they're using right now, and they use it with 98% accuracy. So again, a very young student that developed this idea on how to locate it. Hannah is a student who was dealing with asthma pretty badly, and so she developed a handheld device that reads oxygen levels in real time. It comes through her phone. Really, she did it on a 3D printer, really cool. And then Sabam was a student who wanted to help out students who needed to use Braille to read. So, and kind of, to communicate. So he used Legos to build a Braille printer called Brago. And so these are all things that are out there in our world right now. And they were created by those students who are sitting in our desks and who are there today and who are going to be there when we see them tomorrow. So it's really important that, we give our students opportunities to solve problems in a creative way because the potential that they hold is limitless. So really, really important that we're doing those things. So how do we do that? And what do we need to do? And how do we go about doing that? We're going to jump into that right now. We're going to talk to that through these kind of 4 big ideas. So we want to prioritize and promote play. We want to incorporate opportunities for creative problem solving. We want to cultivate collaboration. And then, of course, we want to foster weirdness. Now we're going to go talk play first. And, as elementary teachers, which most of you are, we do a really good job of this. It's simply because our kids are younger, and we recognize that play is really important and essential for their development, especially in those early elementary grade levels. So using things like the counting bears and dominoes and and fake money and all those in building blocks, all those good things that we have in bins that we may use at centers or stations. But something happens as students move up through the grade levels and to middle and high school, and we don't pull those toys or those manipulatives out nearly as much. In middle school, we can think of these tools as calculators or protractors, or there's lots of different tools that our students are using that are actually tools. Graphing paper is another one. And in high school, we can give our kids data sets, right? And they may not know what those connections are, and that's exactly the intent. So we call this strategy messing about. So it's where we give students these manipulatives before the intended learning actually happens. So before we jump into the objective of the lesson, we put these out for our students to kind of use use and learn and explore. So that way, when they do have to use them, they have a little more context around and the meaning, what they mean to them, and how they can use them to solve the problems that they're going to be approached with. So think about, how else you could use manipulatives in your classroom from K all the way through 12th grade and honestly beyond. And I say that simply because there's research behind this idea that students really deeply learn something, math in particular, through the CPA progressions. And that's where we model something concretely. So we give them those manipulatives, right? We let them play with them, we let them figure it out, and we have them model something with those manipulatives. Then they move through this process and they have to draw it out pictorially. So they have to make representations of what they just did concretely and put them into a pictorial representation. So right there, we can see that there's some creativity involved. And then they take that to the next level by solving it abstractly. So whatever the big concept is, we want to move them through this progression. And you could see here that, it starts out pretty simple, right? When we're giving them a concrete, simple idea, then it moves to a moderate level and then a more complex. And once they reach this complex level, it tells us they're ready for that pictorial stage, and we work them through that process all the way through until they have a really great understanding. And really, we're looking at a target area here in this abstract area. When kids can think abstractly about something, we know they really have an understanding around it. So that talks to how creativity is really powerful. Those first two stages, the modeling it concretely and drawing it pictorially, involve that manipulation of objects, but also then representing that in some way visually. So when we're looking to do that, it's important that we're really intentional about doing that. So it sounds so silly to say this, but just finding spots within whether you do kind of old school like I used to do in the lesson plan book and you write it all out, or if you're on the computer, however you're doing your lesson planning, your scope and sequence, if you work into those individual lessons, just opportunities for messing about and just talking through what that might look like. It just, if we write it down, chances are we're more likely to do it. So just by putting it there gives us kind of that space that we need to make sure we're doing it. So the next one I want to talk to is this idea of incorporating opportunities for creative problem solving in math and science. So one way to do that is through open-ended questions. And when we think about open-ended questions in math and science, there are lots of ways that we can do this. And so we have great PD sessions around this topic in particular, but just a really great, easy place to start, something you could absolutely do tomorrow in math, is just to look at that math worksheet their students may be practicing their work through. And a closed question might sound like this: round 37.67 to the nearest 10th, right? So it kind of leads us to believe that there's only one right answer. A way to flip that is to make it more open is to maybe write something like this, reword it like this: generate 3 different numbers that when rounded to the nearest 10th give you 37.7 or 37 7/10. So again, that kind of statement alone opens up the idea that there's more than one answer to that problem. And that's exactly the direction we want to go. So even if you just take 5 problems from that worksheet and flip them in this way, it's a great start. In science, same type of thing. We all know we have certain curriculums we have to use, and some of those investigations are very scripted, and we know we have to do that. So what's a way to take that step-by-step investigation and just make it a little more open-ended? Some questions we can ask after they do the investigation or while they're doing it: what patterns do you notice? What materials will work best? How are they alike? How are they different? What makes this happen? And then also, I love this question: how do you make sense of this? So when they see something happening, asking students themselves, how do you make sense of this? It really gives us a good perspective on how they're internalizing it and if they really fully understand what they're learning. And also, how can we find a new way to do it? All great questions that really kind of turn that situation from a closed situation or problem into an open one. Another thing that we can do is this idea of creative storytelling, right? And we can do this in math and science in lots of ways. One way to do that is just to simply show them a picture that's very random, like the one you see here, and just ask them, what math story does this picture tell? And I just to try it out, I tried it out with my first grader, and she came up with a great word problem just from what she saw on the screen that you're seeing now. So I thought that was like, oh, it actually does work. And then in science, another, and I have to, I'd say this is another great way to do it. Again, show them the same picture and say, how can you use this picture to prove or disprove a scientific theory? Now, the idea here is that we're not going to say, oh, yep, they've got that theory down. But in a sense, we're checking, we're seeing how they're interpreting the information that they know. What is it that they know, and how are they making sense of it through something like this, through a creative picture that maybe at first doesn't have any direct connection. So seeing them kind of make those connections can be really powerful. Another idea that's kind of plays off of that creative storytelling is a strategy called Prove It. So one way to do that in math is just to use challenging riddles to get students to kind of think deeply about any mathematical situation you may be working on. So one example is here. So some of the cards from this pack of cards are lost. So if I deal among 4 people, 3 cards remain. If I deal among 3 people, 2 cards remain. If I deal among 5 people, 2 cards remain. So how many cards are there in this stack? Now, if we were to give this to our students, if we put it up on the board, we're going to see lots of different ways that students are trying to figure this out. Some might be drawing visuals, some might be trying to do the math in their head, some might be writing out some sort of problem. But this is exactly why this can be really powerful. And you can even offer up an answer. You could say, "Is my answer correct?" and offer an answer. And that kind of goes to the idea: did I get the answer correct, or is my answer incorrect? And figuring out and having kids kind of work through that thought process. Really powerful. In science, and I stole this idea from my son's science teacher. So he's had a rock in the classroom since school started, and it's just been sitting on its own little shelf, and he hasn't said anything about it. But the kids have been asking him lots of questions, and so he finally, a couple weeks ago, told the story about this rock and how he said it's a rock that dates back to the dinosaurs. So dinosaurs actually walked on this rock. And so he built this big story behind it. And then he asked his students, he said, prove that I'm wrong or prove that I'm right. And so I love that because it really encourages students to think about a lot of different things, right? There's so many different directions they could take that question, and getting them to prove or disprove what the story he told. So another great way to kind of build in the idea of creative storytelling in math and science. And so the next idea we're going to talk about here is how we can cultivate collaboration. And we think about collaboration and creativity. Sometimes we may think of it together, but there are really specific things we can do to talk collaboration and creativity. And we know when we have our students working together, some of the best ideas come out of that collaborative group work. So one strategy to kind of think that way is that the idea of power in numbers. So the strategy is called Build a Mascot. In math, you could call it Build a Mascot, but you have an objective where you ask your students to build a mascot that represents your understanding of, and then fill in the blank, whatever it is you're learning. Maybe it's mixed numbers. Okay, so you state criteria and constraints around their building. So again, I think we're doing some engineering now. So the criteria is what does it need to do? Well, maybe it needs to be at least 4 inches in length or height, and it needs to meet the objective, which we just said was that it represents their understanding of mixed numbers. The constraint, though, around that, what are they limited to? They must only use the materials that you or your group selected. So you have students come into the room and they are to gather 2 or 3 items off of a table. So if there's 5 people in their group, you can see that if they grab 2 items, they have 10 items to work with. So again, there's definitely power in numbers. And then maybe you model, if you want to show that actually group work is essential, and really leads to success, have a couple of students work on their own with their 2 supplies. Now, it doesn't mean they can't come up with something really great, but the idea here is that it's even better with the help of others. And so in science, you might say build a mascot that represents your understanding of Newton's 3 laws of motion. And so again, just ideas around how we can take something this kind of creative idea and use it in math and science. Another way is to have our students take their ideas, and we know that when they're working together, part of understanding what it is that they're actually learning is how they communicate it to their peers, but also to us and to the public, right? It's a really essential life skill to have, how we communicate our ideas effectively. So one way to do this is just to have students draw it out. So anytime we can kind of take their ideas and have them synthesize them, through drawing is really powerful. And so if you haven't heard of the locker problem, it's out there. It's out there in the educational world. You can Google it, but it's a great kind of open-ended problem-solving situation for upper L and middle school. But this just shows this class worked it out in two students worked it out separately in 2 different ways. They kind of shared the space on a poster. Fiona worked it out one way, and then Josh worked it out another way, but they are both able to visually express that. And then the power behind that is that then they have to get up in front of the class or in front of a group and explain their thinking. And this is helpful because I don't know if you've ever, just think back to like if you had to give a speech at some point, like in high school. I remember hating that because I had nothing to look off of, right? I was just memorizing the speech that I certainly don't remember today, but I had nothing to go off of. So this is powerful because it gives students a place to kind of, let their ideas flourish. And when they're talking, they can explain from just because they remember they've created this piece. In science, I love this picture of the inflammatory response that occurs after a mosquito, bites you. And so these students drew out what that might look like. And again, so when they present it, they have something to go from, and that really they synthesize their information in a certain way. So again, drawing out another powerful way to get our students to demonstrate their understanding and communicate effectively. And then this last idea here that we're going to talk about is fostering weirdness. And so I love wording it that way just because it stands out, it resonates a little more. But really what we're doing here essentially is getting our students just to think differently. Okay, so and to think about things that might not play out as we normally intended. So one way to do that in math is to just simply ask them. So if we're looking at a problem, so how can we solve 3 times 6? We might have a student who demonstrates their understanding of that by drawing equal groups. And so they draw, 3 equal groups of 6 in this something in sort of like this here, equal groups. Then another student maybe draws an array. And then just to keep asking them to find another way, find another way, find another way. So then we, maybe the next student does skip counting. And then maybe the next student does repeated addition. And those first, say, 4 or 5 responses are probably going to be what you expect. But maybe we can set set a limit around it. Maybe we say, hey, we need to get to 10 today. So we need to get to 10 different ways that we can express our understanding and how we solve 3 times 6. So again, those first few will be what we expect, but think about how students might demonstrate their understanding the further in they get. And so any opportunity we can get to see what 9 and 10 might look like, it's probably a bit of a creative approach, and it does involve some critical thinking. And we're focusing on this webinar today around creativity, but think about how they go hand in hand. In order to think creatively, you also have to have some level of critical thinking occurring as well. So I love this strategy just for that. And in science, we might, if we're looking for, for a question we can ask is, what is another explanation for what the evidence shows? So again, if you're just looking for them to kind of demonstrate another way, this is a good question we can ask. What is another explanation? Because so many, when we interpret evidence, oftentimes there's lots of different reasons why we interpreted it the way we did. So getting lots of different explanations of that is really important. And again, all going back to the idea that how I interpreted the evidence may be very different than how the next person does. So pulling out ways to do that by asking our students to find other ways, really, really powerful. And if it's just for depiction, we just want them to represent something differently. Another great opportunity in science to show that. So what is another way to represent your findings? Maybe somebody did a bar graph. Maybe somebody showed that in a different way. So getting them to really be explicit about why they represented that way and how they might be able to do it differently is really important when we talk about that creative, but also that critical thinking kind of working hand in hand together. And also, I love this idea that all it really does take though is changing the conversation. And so oftentimes there's this kind of connotation around the word weird, right? Oftentimes kids don't think weird is cool. And so how do we get kids to think that weird is cool? How do we get that vocabulary back into our students' kind of realm of understanding that it actually is a really great thing to be different? And so some things that we can do to support that in the classroom is by saying things in both math and science like, wow, that's such a wonderfully weird idea, right? everything around that has this positive kind of feel. Or something like, I'm impressed how you taught about that in a creative and weird way, right? It's again, we're emoting positivity. And then maybe if they give something that's somewhat like a simple explanation, maybe we can say, now, how can you think about that in a weirdly different way, right? So not only a different way than you just said, but something that's weirdly different. And so getting them to think about how weird actually is a great thing, and it's really important. And so there's some, in your hyperdoc, there's some great articles linked to all these ideas, but I do love one of them in particular that's in this section of fostering weirdness, that kind of speaks to why weirdness is important in education. So take a look at that when you get a moment. Oops. And now that we've kind of walked through 4 big ideas with lots of strategies underneath each of them, I'm curious, which of these big ideas do you wish to make a priority in your classroom? And you can select, I believe you can select one of the following. So it's prioritize and promote play, incorporate opportunities for creative problem solving, cultivate collaboration, or foster weirdness. And you may choose off, you might maybe think to choose all 4, but what's the one? If you had to only pick one, what would that be? And Robin's launching that for us, so feel free, Robin, whenever you're ready to close that out.
All right, still trickling in a little bit. I'll give them like 5 more seconds.
Perfect.
All right. So, looks like incorporate opportunities for creative problem solving is at the top, was at 60%, followed by cultivate collaboration at 20%, followed by prioritize and promote play at 13%, and then foster weirdness at 7%.
Awesome. All right. Well, there will be, like I said, you're going to get a hyperdoc if you haven't accessed it already. You'll be hearing from me very soon, and I'm going to. It's a living and breathing document, so I'm going to be adding to that over the next couple days. So, and it that also, I also want you to know, you could reach out to me if you have something specifically you're looking for. I could definitely help hunt that down for you. And again, all of what you've heard today, will be linked in that hyperdoc. You'll also have access to this recording and all that good stuff too. But I want to, before we end today, it's crazy how fast these half hours go. I want to tell you about next month's webinar. So my colleague Tara will be presenting Behind the Words, Infusing Critical Thinking in ELA and Social Studies. And this is a great play off of this month. So please make sure, if you get our emails, to jump in and register for that. And if you don't get our emails, you can definitely go to our website to find how to get to this webinar to register. I love this quote, though, that critical thinking narrows and creative thinking expands, but they must work in tandem for problem solving and decision making. So again, the creative ideas and thinking is just as equally as important as the critical thinking. So join Tara next month for that webinar. And I just wanted to take a moment to say thank you. Again, I know I truly value your time, in this time of year especially, because we are so close to holiday break and you guys are wrapping up 101 things all at once. So thank you so much. When we end today, there will be a really quick survey, and we'd really appreciate it if you just take a moment to fill that out. It'll say, it may say close before the survey pops up. That's okay. You just hit close and that survey will pop up for you. It's just a few questions. And then, speaking of questions, if you have questions, please feel free to reach out to me at jamie.mcpherson@vaei.org. Thank you again so much for joining in, and we hope that you can join us next month as well.